Okay, welcome back. Today we are going to start talking about section 7.2, talking about properties of rational exponents. For the most part, these are things that you guys have all seen before, so I'm kind of going to breeze through them kind of quick. Plus, you guys can read as well as I can, so but it doesn't matter if your exponents are fractions. So for instance, this first one here, looking at 3 to the half and 3 to the 3/2. Okay, it's going to be the same thing as if I gave you like 5 cubed times 5 squared. Okay, it's going to be the same thing. Okay, you guys know that you need to add those exponents, and your base is going to stay the same. So 5 to the 3 plus 2, or 5 to the 5th. Okay, the key here, if we're going to use this, those bases have to be the same. That's why I get a 3 and a 3. If I'm going to add these fractions, okay, remember, if you're going to add fractions, you need common denominators. So in this case, 3 to the 1/2 times 3 to the 3/2, add 1/2 and 3/2, and you end up with 3 squared. Now, this is something that you can either type into a calculator or evaluate. You can actually tell me what 3 squared is. 3 squared is 9, so that's what I would like you to do there. If you get to the point where you're working with variables, obviously if this was an x squared, you don't know what x is, so you can't do that, so you just leave it there. But with numbers, actually tell me what you get. Second property, if I'm taking a power to a power, so 4 to the 3/2 squared, okay? You multiply those two exponents, so I get 3/2 times 2. Remember to multiply across multiplying fractions, multiply across the top, multiply across the bottom. So in this case, you're going to end up with 4 cubed, which is 64. This next one, okay, everybody wants to overuse this one way more than they should. Okay, this only works with multiplication. So a times b to the m, okay, you can think of this as a little mini distributive property, and distribute that exponent to both of them. So if I take 9 times 4 to the 1/2, take the 1/2 to the 9, 1/2 to the 4, 9 to the 1/2, 4 to the 1/2, square root of 9 is 3, and square root of 4 is 2. Remember, 1/2 means take the square root of those. 3 times 2 just ends up with 6. And yes, it is a coincidence that 9 times 4 is 36, and if you take the square root of that, you get 6. It may not always just turn out that nice and easy for you. Okay, negative exponents. We always want positive exponents. We talked about that in the last chapter. Okay, so if I have a negative exponent, that just tells me that that base is in the wrong position in the fraction. So if it's up top, like it is here in a to the negative m, that just needs to go to the denominator. I take that whole thing away, so I just have 1 over a to the m. And then just leave your answers as fractions. So if I take negative 25, or 25 to the negative 1/2, okay, that negative tells me that I need to go to 1 over 25 to the 1/2, which is, remember, 1/2 being that square root. So square root of 5, or 25 is 5, so I end up with 1/5. If you are dividing and you have the same base, so in this case 6 and 6, okay, you're going to subtract your fractions just like you did with your addition in the first property. Subtract those fractions, you need those common denominators. So 5/2 minus 1/2 ends up with 6 squared, or 36. And the last one, if I'm got a fraction, distribute that exponent to both top and bottom. So 8 to the 1/3 over 27 to the 1/3, okay, cube root of both of those gives you 2/3. So taking a look at those, I have 5 to the 1/2 times 5 to the 1/4. Okay, right away my property tells me that I need to go 5 to the 1/2 plus 1/4. Okay, in order to do this, I need to make some common denominators here. So I would probably pick a common denominator of 4. So I'm going to change my 1/2 to 2/4 plus 1/4, which equals 5 to the 3/4. And this one I'm actually just going to leave since it doesn't simplify out nicely. 5 does not have a perfect fourth root so that I could cube that. Then B, okay, distribute my 2 to both of these, so I end up with 8 to the 1/2 times 2 times 5 to the 1/3 times 2. So 1/2 of 2 just gives me 8. 1/3 times 2 helps. Think of this as 2 over 1. And I'm going to multiply that by 5 to the 2/3. So, and again, feel free to just leave that since 5 does not have a perfect cube root. C, I distribute my -1/4 to both of those exponents. Okay, so this is going to combine a couple of them, just like we did in B. So distribute to both of them, and then multiply your exponents. So I'm going to take 2 to the 4th times -1/4, and I'm going to multiply that by 3 to the 4th times -1/4, which is going to equal, okay, again, multiply those fractions. I'm going to get 2 to the -1 times 3 to the -1. Okay, -1 exponents tells me that the 2 and the 3 are in the wrong spot. So I'm going to go 1/2 times 1/3, which allows me to multiply my fractions and get 1/6. D, nice little refresher here. You're going to have, I have 7 over 7 to the 1/3. So I don't see an exponent on that top 7, so that's going to be 1. So I'm going to end up with, okay, fraction, same base. I just got to subtract my exponents. Remember, always subtract top minus bottom. So you're going to go 7 to the 1 minus 1/3, or get 7 to the 2/3. And again, 7 does not have a perfect cube root. Just leave it like that. That's fine. Really, unless it comes out very, very nicely, I'm not going to expect you to go past like 7 to the 2/3. E, we're actually going to use this bottom property here, number 6, but we're actually going to use it in reverse of how I showed it to you. So it's going to make simplification a little easier for us. So I'm going to end up with, okay, I'm going to have put brackets in here, make this a little easier. I'm going to have 12 over 4 to the 1/3. So just took that 1/3 power off the 12 and the 4 and took it outside those parentheses. And then I'm going to square that whole thing. Okay, now I know what 12 over 4 is. Okay, 12 divided by 4 is just 3. So I'm going to end up with 3 to the 1/3 squared. And again, I can multiply my exponents. So I end up with 3 to the 2/3. And again, no perfect cube root. So go ahead and just leave it. Now, working with radicals a little bit, okay? If I've got this situation, notice I have both the cube root of 4 and the cube root of 16, okay? I cannot take and find a perfect cube root of 4 or a cube root of 16. But since I'm taking the cube root of both of those and multiplying them, what I can actually do is set up the cube root of 4 times 16 or the cube root of 64. Okay, you guys have done this with square roots before. Now that property is just going to extend to all roots that we're working with, whether it's a cube root, a fourth root, whatever it may be. Now, I know the cube root of 64. What number times itself 3 times is going to give me 64. Magic number is going to be 4. Again, looking at B here, we're going to use kind of the same idea here. I'm taking the fourth root of 162 over the fourth root of 2. I can rewrite this as the fourth root of 162 over 2, which 162 over 2 is actually 81. And I can take the fourth root of 81, and that should be, and I'm not going to put this plus or minus, because they put the fourth root in the problem. So if they don't tell you plus or minus, you can take it as the plus. If they give you that negative, you need to take that as the negative. But this is just going to be 3. The last thing I want to talk about before we move on this slide here, we're going to talk about simplest form. So what that means is we're going to remove any perfect roots. Okay, so you guys did things like this. So if I give you the square root of 50, you guys know that 25 multiplies into 50, and 25 is a perfect square. So we're looking to do that. Now we're just making sure that we get those with higher powered roots, whether it be a fourth root, cube root, whatever it is. And then we need to rationalize any denominator. And what that means is if we have a fraction, the bottom of that fraction, okay, you can't leave any roots in there. And going with that, you can't have any fractional exponents. So again, we talked about rationalizing denominators with square roots before. So I've talked to you guys for the last 3 years about how you can't have a square root in the denominator of a fraction. Again, just extending that to anything that is not a square root. Again, cube roots, fourth roots, whatever you're working with. So we're going to write these expressions in simplest form. Okay, cube root of 54. Okay, I need to look for perfect cube roots in there. So, okay, if you don't know what perfect cube roots are, actually go to your calculator. And honestly, here's what I do if I get stuck. I'll take 2 cubed, see if 54 divided by 2 cubed works. Okay, if that works, great. If not, I'll take 54 divided by 3 cubed, move on to 4 cubed, 5 cubed. So it's a little bit of brute force, but it does get the job done, and you can get there. Okay, the perfect cube within 54 is actually 27 times 2. Okay, 27 being that perfect cube root. I can break this into the cube root of 27 times the cube root of 2. Cube root of 27 is 3. I don't know what the cube root of 2 is. It doesn't come out nice and perfect, so I just leave it as 3 times the cube root of 2. B. I'm actually going to do something a little different than what we did with square roots. You can still do the same thing where you multiply by that, where you can multiply by that same root in the denominator. However, if I take the 5th root of 3/4, okay, I can actually multiply my fraction by a fancy form of 1. So I'm looking for a perfect 5th root that 4 would go into. Okay, the fifth root that 4 goes into is actually 32. 2 to the fifth is 32. Okay, so to do that, I multiply 4 by 8. But if I multiply 4 by 8, that means I have to multiply 3 by 8 as well. So 8 over 8 is just 1, so I'm really not changing the value of my fraction. I'm just changing how it looks. So I end up with the fifth root of 24 over the fifth root of 32. Okay, with 2 to the fifth being 32, that's 2. Therefore, I'm not going to have a perfect fifth root of 24. And so we can just leave it like that. This is a situation you don't run into a whole lot. Most of the time, it's kind of a special situation. You can do stuff like that, but that's fine. We'll work with those as they go. The very last thing that I want to talk about, and you guys are probably sick of listening to me already, or you already have me on double speed. Like radicals, okay, means the same index. Okay, meaning I'm taking the same root, and I need the same radicand. Okay, just a refresher, that's the number under your root, whatever it is, okay? Doesn't have to be a square root, that's just easy for me to put up there real quick. Now, you're probably saying to yourself, how can I simplify this? I don't have any square roots or roots at all, okay? So, remember, 1/5 power means I'm going to take the fifth root. So I'm going to have 7 times the fifth root of 6 plus 2 times the fifth root of 6. Okay, and you can think of the fifth root of 6 as like your x's or whatever. That's fine. It's really just counting how many fifth roots of 6 you have. So you're going to take 7 plus 2 times the fifth root of 6, and you're going to get 9 fifth root of 6. So really just collecting your like terms like you guys have been doing for a while. And the last one, okay? So first thing I got to ask myself, am I taking the same root? Cubed root and a cubed root, so I'm good. Okay? Same radicand. 16 and 2 are not the same number. You guys know that. That's not a secret there. But can I simplify? Are there any perfect cube roots in 16? Well, okay, hint, if I'm giving you this problem, you should probably have a cube root of 2 left over, meaning that I can break the cube root of 16 into the cube root of 8 times the cube root of 2. After I do that, I'm going to subtract the cube root of 2. So you may actually have to simplify some of these before you can just go and subtract. So cube root of 8, what number times itself 3 times 8? That's 2 times the cube root of 2 minus cube root of 2. So if I have 2 cube root of 2's and I take 1 cube root of 2 away, so if it helps, okay, imagine there's an imaginary 1 there. That's just going to leave you with 1 cube root of 2, or just the cube root of 2. All right, there's your homework. If you guys have questions, feel free to come see me. Talk to me, study hall, before school, after school, whenever. Just let me know. Feel free to shoot me an email if you need to. Other than that, I will see you guys when I get back, and I will see you guys then.